If you've ever wanted to use drawer slides in one of your woodworking projects as part of a Fusion 360 model, like we've got right here, I'm going to show you how I accomplish this in Fusion 360. We'll go through a couple versions, a static version that doesn't operate or pull in and out, but is used primarily to just illustrate the presence of a drawer slide like you would see in this sort of cutaway drawing. And I'll also take you through creating a drawer slide that actually operates and functions like a normal drawer slide does when it's pulled out and pushed back in. So stay tuned. As you'll no doubt discover as you watch this video, I talk really slowly. That's probably because I grew up in the Ozark Mountains in Missouri. But in all seriousness, the intent here is to talk slowly enough that if you want to use this as a training session with your own version of Fusion 360, following along side by side, doing and repeating the steps that I go through, you can do that. If, however, your intention in watching this video is to just get the concepts down, I suggest you set the playback speed to something more like 150%. You'll enjoy it a lot more. In Fusion 360, there is a built-in facility to insert components that are available through McMaster-Carr. Let's start there. Just as an example, I'm pulling up the dialog box to search through the McMaster catalog. Let's key in drawer slides. And this is the drawer slide that I'm after right here. It's a self-closing drawer slide. This is a side-mounted type of slide. They list a number of versions here in lengths, and there's even a version in 304 stainless steel. Let's take this 18-inch version right here, and we want to bring it in as a step file, and we'll download it, and there it is. So we've got some positioning arrows here we can use to rotate the position within this model. I've started a new design here to capture this drawer slide. Let's first turn on the origin. I like to get some consistency here in how my parts are used in the woodworking projects that I design in Fusion 360. And this is not exactly how I like it. Let's see, let me orient this around. The blue is the Z-axis. I like that pointing up. The green is the Y-axis. I like that pointing front to back in my projects, and the red axis is right to left. So as we can see, this slide came in here in the wrong orientation for use. I want this running front to back, and it's laying on its side. So let's fix that here with this positioning instrument. Let's first turn it around so it's pointing front to back. If you look over here at this dialog box, we've moved it 90 degrees, which is good. Now from the front-on view of my projects, it's laying on its side, so let's fix that. I'll turn that this direction. You can see we tilted it here 90 degrees, and now it's in the right orientation. My intent here is to create a slide that I can use in my woodworking projects and save this as a component that I can pull into other woodworking designs and use as a part. So let's first save this, and I'm going to call this 18-inch drawer slide. And you can see it's appeared over here in our panel on the left. The next step here would be to get this drawer slide in its fully collapsed form. But before we do that, let's see what we have here. This came in from McMaster as a step file as a component, and within that component there are a number of bodies here. We want to convert those two components themselves so that we can apply joints to them in a little bit. But first, let's see what some of these bodies are. I don't think we need everything that's here in this model. So let's start turning some things off. All right, so that's the rail that attaches to the side of the cabinet. I'm going to give that a name here. Cabinet rail. And let's turn that off just for clarity. What do we got here? Okay, this is the mid rail between the one that attaches to the drawer and the one that attaches to the cabinet. So let's call this mid rail. Got that. And we can turn that off. What do we got here? Okay, we got bearing races here, 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 and here. And if we click on them, they show up as underlined in the browser over here. So we don't need that for this purpose. So let's remove it. Here's the other one. Let's remove that. We can remove this one as well, and this one here. So that's body 6. So what do we got left? Okay, that's the cabinet or the drawer rail that attaches to the drawer side. So we'll give that a name. And then this last thing here has to be that rubber bumper at the back. So let's just call that the bumper. Of course, you don't have to do all this naming. I like to do this just to keep things straight in my head. Now, those are all bodies. We want to join them together into a single unit. So that we'll do that using joints. But first, I want to get these converted from bodies to independent components so that we can actually manipulate them as with joints. You can't create an assembly from bodies in Fusion 360. In order to create an assembly where there's a defined relationship between two parts, those parts first have to be in a component form rather than a body form. So let's convert these bodies to components. So there we have the components that are part of this drawer slide. And now we can start doing some positioning operations to get this thing fully collapsed. So I know that the front tab on this component that attaches to the drawer, when it's closed, aligns with this area here on the back of the drawer slide that attaches to the side of the cabinet, this surface right here. If I could get it highlighted, there we go. So we're going to use the align command here to actually get this position correctly. So here we've got an align going on, and it wants to know from the part that we want to move from. So I want this front surface right here, and notice I can pick lots of locations on here with those little coins showing up. So I don't really want to align the center of this surface with anything. I just want to align the surface itself. So we'll pick that. And then the component here is this surface right here, and same thing going on there. I just want the surface, not any of the points on it. All right, so you can see here now that that component that attaches to the side of the drawer has actually been moved backwards, and it hasn't been altered in any other way other than aligning that surface with this surface. So we'll call that good. Now, just for clarity, I'm going to turn off the rail that attaches to the side of the cabinet here, just so we've got a little bit better visibility. And I know that when this slide is fully closed, this surface on this mid rail, that surface right there, actually collapses and aligns with the back of this tab right here. So let's use the align command again to accomplish that. So here's our align command, and it wants to know from. So we want this surface, but we want the surface, not any particular point on it. There we go. And to make it easier to find that, let's turn off the mid rail and go around here. And our 2 position is right here. And if we turn the mid rail back on, you'll see that it has in fact moved that mid rail component to a position where this surface is aligned with the back of the tab on the part that attaches to the drawer. So we're in good shape there. Let's turn the cabinet rail back on. We've got another component here, this bumper. So we'll turn off some things here. Right now this bumper is free to move around, and we want to attach that. It's positioned correctly, but we want to attach it to this side. We also want to fix the other ones in position. Let's get rid of the origin marker. We don't need that. So I think we've got pretty much the model that we want or after here. The only problem is all these things are free to move around. So watch this, see? And I'm going to do a Control Z here to bring that back where it was originally. So for assemblies like this, where we're going to create joints, the first thing I like to do is to anchor one of the components so that it can't move around in 3D space. We'll accomplish that using a command called ground. So let's take this cabinet rail, for instance, right here, and let's ground that. So if I right click on cabinet rail, we've got a ground command that pops up here. So we're going to capture all the positions here, and now that rail is grounded. If I wanted to move that around with a mouse, I wouldn't be able to. But these other components here, the mid rail and the drawer rail and the bumper, those are still free to float around. So the easiest way to combine all these into one assembly that can be used for importation into another model under this thing would be to create a rigid group here under assemble. We can select these 4 components and create the rigid group there. You notice it created a joint here, and we can turn that joint on or off, but let's get this thing ready to save and use. So I guess I'm happy with that nomenclature there. It tells me the McMaster part number, self-closing drawer slide. We'll just keep that for the name of this thing and save it away. What if we didn't want to use the drawer slide from McMaster car? You know, they don't tell you what the brand is or much about it. If you have a specific brand that you want to use, most of these drawer slide manufacturers, at least the good ones, are making available 3D models. They're not part of the Fusion 360 package, but you can go out on the web and get them. So let's do that. And we'll use that as a basis for our dynamic drawer slide that we'll create next. So we're going to go to the browser here. I've done a search for KV 8417 drawer slide 3D model. So this is Knapp and Voigt. That is the brand of drawer slide that I like for side mounted. And the 8417 version is medium weight capacity, and it has self-closing and latching facilities. So when I did that search, here it is on the Knapp and Voigt site. Let's go there. Yep, that's the drawer slide itself. You can see it's ball bearing, medium duty, up to 100 pounds, etc. So we can get a CAD model on this. Let's see, let's do the 18-inch version right there. You can see that's the 18-inch. Let's get the 3D CAD model here. Okay, so here are all the various size iterations of that. Let's select the 18-inch. There it is, and it's available in several formats here. This step file is what I want, so let's see if we can get that downloaded. Download the file. Your request is being processed. Preparing the file for download. Well, that's great. Let's give that a second. And we'll click download. Good. So I think we've got it downloaded. Let's see what's in our download folder here. Yeah, there it is right there. So it's a zip file. When we unzip it, we look inside. Indeed, there's our 8417B 18-inch long step file. So we can use that in Fusion. Okay, we're back in Fusion now. Let's close our static slide that we just created here. Now let's go open that step file. So from my computer, let's see, downloads, there it is, and that's a step file. So there we go. Let's see what we got here. We got a bunch of bodies, and let's turn on the origin. And just as I suspected, these things aren't oriented the way I like to work. You know, there's confusing myself now. So let's just go home here and to the front. And as you can see, this thing is straight up and down in my normal workspace coordinate system here. So let's get these things situated properly. This isn't absolutely necessary, but I like to keep things consistent, so let's just do that. So the quickest way to reorient this is to glom them all together into one rigid group and then rotate them around with a move command. But in order to create the joints, the rigid group, we're going to need to create joints out of these things, and to do that they need to be components. So click on the first one, shift, and click on the last one, right click, and we can create components from all those bodies. There we go. Now we can create a rigid group with that, and we can select, click, shift, click, all of them together. There we are. Now they're in a rigid group. Now we just opened that file. There's a couple things I want to do housekeeping wise here. One is I want to capture the design history, so that shows up in the timeline down here. And the next thing I want to do is save this thing. And we will call this 18-inch drawer slide dynamic. So I got 2 8s in there. There we go. So now that's saved, and we can see it over here in the data panel, and it's been pushed off to the cloud. All right, back to getting these things reoriented. Now we've got them combined into a rigid group. We can see that here. We've got a joint that's a rigid group. Let's use the move copy command here to get these things reoriented. So we can pick any one of these components. Let's do this one right here. Wrong edge. Let's try that again. I want to get the flat part of this component right here. There we go. And now we can just rotate this around 90 degrees, and we can see that's our normal front-facing view of the workspace, and the drawer slides are pointing front to back, which is exactly what we want. Okay, cool. Now the next thing I want to do is get rid of this rigid group. So right click on there and delete. I'm going to save that. User saved. There we go. We can turn off the origin. We don't need that. We're going to be working with this model, these components here, to create a functioning slide mechanism. So let's turn this one off. We're going to keep it because we're going to need to reference it later. If I just click on one of the components, it underlines it here in the browser, so we can turn it off. We'll just turn off all three of those. There we are. So I also think it helps to name these components. So let's just click on this one. Component 2 here is the 2 slow clicks, and you can enter into that box the new name. So this is the cab rail. And if we click on the next component, it highlights it in the model. That's the mid rail. And this component up here is the drawer rail. Good. Now we need to take some measurements. Few things we need to know. When this came in its fully extended position, let's just measure it and double check that we got an 18-inch slide here. So on the keyboard I for inspect, and we get an inspector up here. Let's inspect that surface relative to, let's say, this surface right here. 457.302. I'm going to make note of that. I'm going to write it down because we're going to need it when we set the travel limits for how this slide mechanism moves out of the cabinet rail here. What is 457.302 in inches? Let's see. 18.004 inches. Okay, cool. The other distance I want to measure is, I'm not exactly sure how far this mid rail pulls out of the cabinet rail when this is fully extended. We're going to need to know that a little bit. If you just double click that reverse arrow there in this inspection measurement tool, it'll reset that, so we can pick up this surface here and compare it to that surface there. And we get 189.281 millimeters. So I'm going to make note of that. All right. So let's work on the mid-rail to cabinet rail movement. Let's name them as well. So this actually, we did name them already. Sorry about that. Let's turn off the drawer rail, and we're going to define a joint relationship between this component and this surface, actually, and this component and that surface. Now, they're not aligned flat against each other. You can see there's a distance between those two surfaces, and we're going to want to know that, because if we start creating a joint between this surface and that surface, it's going to actually move them together unless we specify the offset. So let's measure what those are. I for inspect again on the keyboard, I for inspect, and this surface relative to this surface, and it's 3.607 millimeters, so I'm going to make note of that. All right, so now we're ready to make a joint, and under the assemble menu here, joint, and we want a slider type of joint, you know, rigid. We've got all kinds of choices here, but we want a slider, and now we can specify what slides against what. So we're going to make this surface and this point right there. If you look closely, there's a little bullseye there with an origin symbol. So we can use that. I call it a coin. Most people do. We can use that as and specify that's what we're going to use as a reference point for creating this joint, and we're going to join it over here on this component. Let's turn off the mid rails, make this a little clearer for you. And we're going on this surface, and we're going to go right there on that point, right there on that surface. And let's turn the mid rail back on, and we'll see if we created a motion joint. And notice that, as I said before, these two have now been sandwiched right directly against each other. We'll come back to that in a second. Let's get this motion fixed first. It's moving side to side instead of front to back. So let's try x-axis and see. Oh, that's up and down. Try y-axis. There we go. So that's the correct motion for the slider. And in terms of the position, let's just grab, we know that this component is positioned out here somewhere, so if we grab that arrow and pull it out, we can see which offset axis we need to specify here, and it's, in this case it's the Z, and we had measured that before as 3.607. And as you can see, we've got the right kind of gaps around there, and there we are. So now we've got a slider. So next thing we want to do is create the drawer rail to cab rail joint. So let's turn off the mid rail, turn on the drawer rail, and same kind of thing here. We need to create some, or understand some distances of how far off this component is from this, right to left. And I'm going to pick this surface right here for the joint, and I need to be able to pick a point right on the front of the drawer slide component here, and I can do that there, and we're going to create a joint of that relative to this surface here. So let's measure this surface relative to the other surface we'll use for reference here, and we'll use that in the joint. So I on the keyboard for inspect, and bear with me here. We're going to compare that to that surface to this surface, and we get 1.016 millimeters. And make note of that. Now we can create the joint. And again, it's a motion slider. And in terms of what we're going to join together, like I said, we're going to take this surface right here and that very front point. Let me zoom in a little closer here. Right there. And we're going to slide it against, oops, this surface here and that point right there. And again, we got the wrong slider motion direction. We got a slider for sure, and x-axis, that's correct. And as you can see, it put those two surfaces right together, and they're actually offset that distance that we measured before. We can see that that's the Z offset here, so 1.016 millimeters. And there we are. We can turn the mid-rail back on. Now before I can actually demonstrate this, we need to ground one of these components. Let's take this the rail that attaches to the cabinet, and ground that, so that's not free to move in the 3D space here. So if we right click on that component we have a ground command here, so we ground that. Yes, we want to capture positions here. And if you look really close, there's a little red push pin here. That tells us that that component is in fact grounded. If we wanted to unground it, we could right click and do that here, but we're not going to do that now. So now that that's grounded, we can move these things around, and you can see that we have the right slider motion and the like here, but we don't have any constraints on the travel limits on any of these. So we're going to tackle that part next. But before we do, let's name some of these joints. Here's a little trick. So slider 2, what is that? How would you know? Well, if you right click on it, you can animate the joint by pulling down here. And that's the joint between the mid rail and the cabinet rail. So let's escape. We'll cause that animation to stop. Let's name that here. Mid to cab. And that would make this other one drawer to cab. Good. A good time to save. So save, user saved. We could actually put some descriptive information in here about where we were in the design process. I don't feel a need to do that right here. We do have some design history captured down here, although it's, for this purposes, it's not probably all that useful. So we'll save that here. Now we need to establish the travel limits, and we will do that next. I do want to point out that we've got, if we turn off the components here, we've got some symbols here. See these little light blue things? So those are the joints. If you click on that, it will tell you what joint that refers to up here in the browser. I find those things kind of distracting in in real models. We can turn them on and off here with this eye. Since we're going to be modifying those, I'm going to leave them on, and we'll come back in a minute and do the travel limits. In order to do the travel limits here, it would be really helpful to get these components back in their relative positions as when the slide is fully closed. So we have a fully closed slide. It came in with our open command. So let's get those illuminated, and what I want to do is get those fixed together so they're not likely to move around. So we're going to assemble a rigid group, and I'm going to select these 3 components, and now this slide that came in originally is all the components are in the right place relative to each other, and we can use that as a reference to get these aligned up here on top. So the first thing I want to do is get this cabinet rail aligned with this cabinet rail in terms of the front 2 faces. So here we go. We're going to do an align command. We'll zoom right in here. We want that surface aligned with this surface here. And looking at it from the side, there we go. Now the next thing I want to do is ground this. So right click. Do we have ground here? No. But we do over here. So we right click on this and ground that. So this component now is grounded in space, 3D space. It can't move around. So let's start aligning the other 2 components. So we're going to align, let's do this surface next. Surface here with this surface here. There we go. And let's turn this off down here so we can see what we're doing with the mid rail. And let's align, repeat align, and we're going to align this surface here with this surface here. Great. And I can turn our drawer rail back on. We don't need these anymore. So those are in their proper position. We're going to capture the position here. And that's going to show up in our timeline. So we can always go back there if we want to. Now, we need to establish some travel limits. Let's work on, how about the mid rail to cab rail first. So since we're going to be working on the mid rail to cab rail travel limits now, so just to get some clarity here, let's turn off the drawer rail so we know what we're working with. We've got our joints defined up here. There's our rigid group that was these three components that we used for alignment. We don't need that in this process, but let's establish the travel limits for the mid to cab here. And if you hover over it, there's a little orange arrow here. And if you click on that, we can edit joint limits. And let's open up minimum and maximum. And the really tricky thing here, this is really fussy. I don't like this interface. I've told Fusion team about this. They sort of agree. It's pretty clunky, but it does work. So this is the minimum and maximum travel positions. Not the distance, but the positions. So the other thing is that the minimum position here has to be the smallest numerical number between the two. So if the maximum position is -12, for instance, the minimum position has to be less than -12, so -15 or whatever. But let's put some travel limits in here. If you remember, we took a measurement of this surface here on the front of the mid rail. When it's fully extended, how far is it out from its normal position? And we had measured that at 189.281. I made a note of that. So let's make this 0, and that you can already see is relative to the face of the model here. Now that's not where it started, so I'm going to go backwards a little bit here. That's where it begins. Let's measure that. So that setback is 3.327. I think we may have measured that before. And let's try our travel limit here again. And we'll open the minimum and maximum. And let's put, it's not 0, it's -3.327. Okay. And the maximum was 189.281. That looks pretty good. So we got that travel limit established. And let's try the next one. So let's turn off the mid rail and turn on the drawer rail. And is this thing sitting proud of that edge there? Let's see. Let's inspect it. I think it is. I think we may have measured that before. So from that surface to that surface, yeah, 1.016 millimeters. So that's probably our minimum travel. So if we hover over this drawer to cab joint, we can click on that orange arrow and we can get our minimum and maximum here. So here's our 1.067. I got too many zeros in there. There we go. So you can see if we move this up, that position, the minimum position a little forward of that front edge, which is correct. And the full extent here was 457.302. well, it isn't 45,307, it's just 457.302. There, that looks better. That look right? Yeah. Okay, and let's go to our home position here. Turn on our mid rail and see what that's our travel limit there. And that's our travel limit there. So that looks pretty good. Let's just do a double check here for sanity and measure this distance back to the front there. We knew what that was to begin with. I for inspect from that surface to this surface, 457,302. So we're good. I'm going to save this, and we'll call it travel limits. Set. Okay. So we've got our travel limits set here, but we don't have behavior that corresponds to real world action. You know, in reality, these components interact with each other, and as this one pulls out, the mid rail pulls out as well, but not as fast. So we can establish linkages between these two sliding joints here and define how one moves in relation to the other. And to do that, it's called a motion link. And I'm going to set this up here, and just to demonstrate how it is, we're going to fill in some data here that define the relationships more precisely here in a minute. But let's just create a motion link between this slide unit, the mid to cab, and the drawer to cab. And you notice it's put in some numbers here. I'm not exactly sure where to pick these, but what it's saying is that when the first joint picked there, the mid rail to cabinet rail moves 10 millimeters. The other joint between the drawer rail and the cab rail moves 20. And so the relationship is kind of right, but let's do this. Let's stop the animation and get these things pulled out fully. And now let's check some things. We know that when this is fully, this rail here is fully extended, we measured it. It extended out from this face here 189 millimeters or thereabouts. Let's see what it is. Come on. There we go. That surface to this surface. 189.281. So that's good. We also know that this surface compared to this surface was 157,302. So we've got that. Let's see if it aha. So it works when it's fully extended, but the slide doesn't close all the way because that relationship in motion is not correct. It's not 2 to 1. Well, what is it? Well, we did take some measurements before, if you remember. We measured when this was fully retracted, this mid rail here. Let me turn off some things. I'm going to turn off the drawer rail. So when this was fully retracted, it sits about 3 millimeters or so further back. We actually measured that, 3.327 millimeters back from the face of this slide when it's fully retracted. And then when it goes all the way forward, it extends 189.281. So we know that number. Let's turn that off. Turn this on. We also know that when this is fully retracted, this surface sticks out in front of that surface 1.016 millimeters, and it extends fully to 457.302. So we can use those numbers to create the motion link ratios here, and I'll show you what we're going to do here. We're going to edit this feature, and we know that the mid rail travels a total of 189.281 plus 3.327 millimeters when it's fully extended. And we know that this other component here travels our 457.302 minus the 1.01 millimeter, 1.016 millimeters, because it doesn't start out on that aligned with the face of that. It's proud of it. So we've got those in there. Let's see. So this will go fully closed now, it looks like. Yeah. Let's turn on the mid rail. Pull this all the way forward. There we are. Now we can double check some things just to make sure and to validate what we're talking about. So when this is fully extended, that surface compared to this surface, 457.302, that is correct. And this surface relative to this surface, 189.281. That is also correct. So we've established the right motion link, let me get it back up here, ratios between the two. I hope you follow that. So we're good there. So let's clean up this model and get it ready for use in some other woodworking assembly. We have these components laying around. Remember, we don't need these anymore, so they're combined in a rigid group. Let's get rid of that rigid group, delete. Now let's get rid of these three components. We did use them for reference in aligning some things. We can try deleting them. Let's see what happens here. This feature is referenced by other features in the timeline, so let's do something else. Instead of deleting them, since they're just referenced and we want to get rid of them, we can, in fact, remove them. So they remain in the model for the purposes of our operations down here in the timeline where we aligned certain faces with other faces, but it doesn't show up in the model as a component. That's what the remove thing is all about. We've got our joints labeled. We've got our components labeled. Let's turn off the joints so we get rid of all these little blue symbols that are scattered around here that represent the joints. And the last thing I want to do is create a new component and put these pieces in it. So when we import this into another assembly, we get one unit representing the entire drawer slide rather than the three components individually. So let's do that. We're going to right click up here, say new component, and we're going to call this 18-inch dynamic drawer slide. There we go. And there it is. And now all we have to do is just drag these components into it. And when we need to use it, it'll come in as one item, like that. So we're good here. I'm going to save this. And we can say motion links established. Now it's pushing that out to the cloud. We do have a joint still visible here. Let's turn those off. There we go. I'll save it again. Now, let me demonstrate how we might use this in a model. You can see we're back to original positions here. When this is fully retracted, this face is the 3 point some millimeters back from that face. This face is sticking proud of it by about 1 millimeter, a little more. So let's test these slides that we've made here and have in the library in a new cabinet design. I'm not going to do the whole cabinet here, but we'll just make a part that represents the side of a cabinet. So we want to work on this plane here. R for rectangle. And we'll make this 400 by 800 millimeters. And now we can finish the sketch. Extrude. Let's pull it out this way. 18 millimeters. There we go. Actually, let's go back and edit that sketch. We'll put some points on there where we want to put the slides. So I've gotten used to using points. So let's just put a couple points on here. So those are in line with each other, it looks like. Let's put some dimensions on here. So from here to here, let's make that 10 millimeters. We can do the same thing here, from here to here. And just specify that number right there. Whoop. D for dimension, here to here. And there we go. Let's pick up the same thing. And we can put some other dimensions on here, I suppose. Let's make that 50. And from here to here, we can make that 100. Now we could have put construction lines on here to do all that. I'm going to end up with a point anyway for placement of the slide. So we'll finish the sketch. We can see our points here. So let's bring in the static slide first. Right click, insert into current design. Whoop, it's telling us we need to save this before we do anything first. Good point. So we'll call this test. And there it is. So now we can right click, insert into current design. We got it. So it's for the other side of the cabinet and it's backwards. That's okay. We're going to create a joint here that will fix that. So we're going to take this surface and that point right there, and we're going to make it a joint right there. And that looks good, except it's flipped. So here's our flip button. And we say OK. And there it is. I can do the same thing with the dynamic slide. Actually, this is sticking out the back. Let's go back into that sketch and make this 500 millimeters. Okay, finish sketch. Now our box is at least deep enough for that slide. That thing came in here with joints turned off, which is good. Let's bring this one in. Right click, insert into current design. There it is. Okay. And same deal here. This is backwards and on the wrong side. So we want to put another joint in here. And just so you know, this is a rigid joint from that position right there down to this guy right here. And that needs to be flipped as well. There we are. Let's turn these joints off in terms of the joint symbols. And there's our dynamic slide in motion. So I think we've accomplished what we set out to do here, and we'll go back to our other woodworking project of designing a cabinet that actually uses these slides. Thanks for watching.